This is something new that we're teaching this year. I'm going to show you why we get the solution that we get. Then I'm going to basically show you a shortcut of how to do this problem. If you think back to how to solve a problem by taking square roots, you do not have a linear term here. So we would subtract 100 from both sides and get x squared equals negative 100. To get the x by itself, we take the square root. X equals, anytime we take a square root, we do plus or minus. There's a negative underneath, so we get I square root of 100. Either you do the factor tree here or you realize, hey, that's just a perfect square, so that's actually 10. So x equals plus or minus 10i is the solution. This is the way that we would solve it by using square roots. They want us to show you how to solve it by factoring. So here's how you would solve this thing by factoring. You've seen difference of squares before where two perfect squares are being subtracted and you can figure out how to solve those. This is something different. It's called sum of squares. So let's just say it's x squared plus 100 equals 0. Here's what you need to do. You need to rewrite each one of these as what's being squared. Well, here obviously the x is being squared, and here there is a 10 being squared. All right? Now, the next step is to write our factors. So we get x goes to each one of those spots. We're going to put a 10i there and a 10i there. Okay? The reason for the I is because of that piece. If it is a subtraction sign, you do not need the I. If it's an addition sign, you need the imaginary piece, so you need that I. Now, you put down opposite signs, plus 10, minus 10. Okay? Set each one of them equal to 0, x plus 10i equals 0, x minus 10i equals 0. Solve it. Subtract 10i, add 10i. X equals negative 10i and positive 10i, which is what we found to be our solution from up here. Okay, so same exact thing. It's just by solving by factoring. So let me give you another problem. Let's try x squared plus 225 equals 0. So if we're doing this problem, again, rewrite it in terms of perfect squares. X is being squared here. 15 is being squared there. Okay? So then your next step, draw your two parentheses, draw your factors. X and 15i, x and 15i. And then you just get different signs, positive and negative. Okay? Set them equal to 0 and solve. You're going to end up with negative 15i, positive 15i. One last different type of example problem. This one gives you something that's kind of weird. So let's say our problem is 4x squared plus 25 equals 0. Well, now x is not the only thing being squared. If you think about what is the perfect square of 4, you'll realize, hey, that's 2. So it's actually 2x that's being squared, and then a 5 that is being squared. Okay, write your factors out. 2x, 5i, 2x, 5i, different signs in the middle. Now, when you set them equal to 0 to solve these, something different happens. So, of course, we subtract 5i to begin with. So we get 2x equals negative 5i. But now you have to divide by 2. So you get x equals negative 5i over 2. And then over here, 2x minus 5i equals 0. Move the 5 across, 2x equals 5i. Divide by 2. X equals 5i over positive 2. So you see a similar type result. However, this time there was something out in front other than just the x. So be very careful. Look at whenever you see something out in front of the x squared. Think about what number is being squared. What's the perfect square that goes here? And that answer is 2, and then we have a 5. Once we get these numbers, we just stick them down here, put different signs in the middle, and then solve them. All right? If you have questions, raise your hand, let your teacher know.